Elements of QbD. Let us move into another important section, the elements of QbD. As you can see, there are six major elements of QbD. One is the targeted product profile, two critical quality attributes, third is linking the material attributes with process parameters and critical quality attributes, and fourth is to establish a design space, and fifth is establishing control strategies, and sixth is product lifecycle management. Let us look into the target product profile or TPP. A target product profile is a prospective and dynamic summary of the quality characteristic of the drug product that needs to be achieved to ensure safety, efficacy, and desired product. It usually includes dosage form, route of administration, dosage strength, pharmacokinetics, and stability. Thus, the QbD program begins with designing a product profile that is called as target product profile, which will include all the variables and all design aspects such as dosage form, its route of administration, dosage strength, pharmacokinetics, and stability. Target product profile is a patient and labeling centered concept because it identifies the desired performance characteristic of the product related to patient's need, and it's organized according to the key section in the drug labeling. Quality targeted product profile. This is slightly different product profiling. Here, this is a substitute for aspects of scientific safety and efficacy that can be used to design and optimize the formulation and manufacturing process. In quality targeted product profile should only include the patient relevant performance of the product. It is a term that is an ordinary addition of targeted product profile with quality in it. It is related to identity, assay, dosage form, purity, stability, and the label. So in reality, quality targeted product profile is the first step in QbD. The formulation scientist has to develop a profile for the product stating what sort of dosage form it should be, what should be the assay and the tests required, and what should be the limits of each parameters and specifications. The next step is to identify or select critical quality attributes. Critical quality attributes are defined as the properties or characteristics, namely physical, chemical, biological, and microbiological, that should be within the appropriate limit in order to ensure the desired quality. Generally associated with the drug substance, excipients, intermediates, and drug product. The quality attributes of drug product may include identity, assay, content uniformity, degradation products, residual solvents, drug release, moisture content, and microbial limits. It also includes physical attributes such as color, shape, size, odor, friability, etc. And these attributes can be critical or not critical. So as a second step, the scientist has to identify which are the critical quality attributes or critical properties of the drug product which is determinant to its quality. Or critical quality attributes helps us to measure the quality of the by measuring the drug content, measuring the residual solvents, or measuring the drug release rate, and measuring the moisture content. All this helps us to identify or measure the quality of the product. So this listing is important as in the development stages. Here are some examples for solid oral dosage forms and other delivery systems and their quality attributes. For a solid dosage form, product purity, potency, product stability, and drug release becomes important, whereas aerodynamic properties of inhalers are important, sterility of parenterals are important, adhesive force of transdermal patches are important, and so on. Moving to the third stage of quality by design. Here, this is one of the important steps where the scientists have to identify critical process parameters. A process parameter whose variability has an impact on a critical quality attribute, and it should be observed to ensure that the process produces the desired quality. That means here, the scientist has to identify which are the process parameters that can affect the quality of the product drastically. That indicates the particular parameter is very critical. Otherwise, if it doesn't affect the quality much, it will not be a critical parameter. It will be a non-critical parameter. So let us see some of the process or operations during tableting, like wet granulation, drying, and milling. Look into wet granulation. In wet granulation, there are some process parameters which are very critical, and they are mixing time, impeller speed, binder fluid addition rate and time, method of binder addition, temperature, and all these parameters actually affects the blend uniformity and drug content uniformity, granule size distribution, and finally the moisture content. Look into the drying. Drying time, inlet air flow, exhaust air temperature and flow are critical to the process. Why? Because it affects the bulk and tap density of the granules. Again, it affects the moisture content of the granules, and it affects the granule strength and uniformity. Finally, it can affect the tablet hardness. Milling. In milling, the milling speed, screen size, and feed rate are important, or they are critical. Why? Because milling speed affects the flow properties, screen size affects the particle size distribution, feeding rate in again affects the bulk and tap density of the output material. So hence, if you look into each and every process, you will find certain parameters which are very critical to the quality of the final product, and they will be identified, picked up, and classified as critical process parameters, and these will be listed by the formulation scientists. Along with critical process parameters, there is another major aspect to be considered as critical material attributes, because the product quality is finally depending upon the input material, the material which comes into the product. A good product cannot be made out of bad raw materials. So critical material attribute of a drug substance, excipient, and in-process material is a physical, chemical, biological, or microbiological characteristics of an input material that should be consistently with an appropriate limit to ensure the desired quality of that drug substance, excipient, or in-process material. So these critical material attributes of all these materials such as API, excipient, and other materials are to be considered in order to develop a QbD program. And the critical material attributes is likely to have an impact on critical quality attributes of the drug product. For example, if the API has a lot of impurities, Ultimately, it will affect the drug content in the tablet produced out of it. Thank you.